The effect of beam weights and crack depth ratio on mode 1, fracture toughness of reinforced concrete beam, an experimental and numerical study. The fracture performance of pre-cracked reinforced concrete beam was investigated numerically and experimentally. The effect of beam weights and crack depth ratio on the behavior of stress intensity factor Q1C and fracture energy G for reinforced concrete beams was investigated. The experimental or numerical programs included 3-point bending test specimens for 8 beams, of which 2 were control beams without any cracks. The remaining 6 beams had different widths and different crack depth ratio. The concrete strength was 40 megapascal with a minimum area of steel reinforcement for each beam. The results of load deflection for cracked reinforced concrete beams showed an increase in the maximum load and decrease in maximum deflection, with increase in the beam width and the crack depth ratio. The experimental and numerical results show that the stress intensity factor K1C values have a slight increase for wider widths, also increase as the crack depth ratio increases. The crack patterns proved that the existing of pre-crack causes a stress concentration at the crack tip, which decreases the number of generated crack on the beam. Conclusion: increasing the beam width results in higher fracture toughness values, both experimentally and numerically. The K1C increases with higher crack depth ratio. When a crack is present, stress concentrates at its tip, causing fewer cracks. As crack depth ratio increases, steel reinforcement becomes more effective.